Hi students, and today we are going to discuss one of the problems related to the fin. The problem is given like this. We'll read out the question before solving the problem, and it's better to understand what we have to calculate it. So now I'll read the question. A longitudinal copper fin of thermal conductivity of 380 watt meter degree centigrade of 600 mm long and 5 mm diameter is exposed to air stream at 20 degree centigrade. The convective heat transfer coefficient is 20 watt per meter square degree centigrade. If the fin base temperature is 150 degree centigrade, determine, first one we have to calculate heat transferred. Second one is the efficiency of the fin. Students, here they are given very clearly what we have to solve, what we have to find out. First one is the heat transferred across the fin and what will be the efficiency of the fin. They have given a longitudinal copper fin is given and its length is 600 mm. Okay, and dia of this length, that is 5 mm. 5 mm dia. It is the temperature of the fin, the base temperature T B base temperature is given, that is 150 degrees centigrade, and the heat transfer coefficient of the air is given already, 20 watt per meter square degree centigrade. So now we have to calculate what is the heat transfer and efficiency of the fin. So we'll write it clearly, what are the things they have given. That is length of the fin is given, that is L is equal to 600 mm. So we have to convert into meter, that is 0.6 meter, and dia of the fin is given, that is T is equal to 5 mm, and we have to convert into meter, that is 0.005 meter. The fin base temperature is given, the fin base temperature, that is TO, okay, or we can it be whatever, that is 150 degree centigrade. The air stream temperature of the air, that is TA, that is 20 degrees centigrade, and thermal conductivity of the fin material is given, that is copper, that is 380 watt per meter degree centigrade, and H is given for the air, that is 20 watt per meter degree centigrade. That is convective heat transfer coefficient of the air is given. So first one we have to calculate Q, that is heat transferred. So here the given problem, we have to neglect the heat loss from the end surface because the heat transfer from the fin is given by. Okay, so we have direct equation, that is Q is equal to KACS MTO minus TA tan hyperbolic ML, where M is parameter, that is HP by KA or K. Further, we have to substitute the values H by 2 perimeter pi d, because it is the cross section of this fin is circular, so perimeter of this one, it becomes pi d. D is given. Now the area, we know that it is pi 4 d square. Okay, so further this equation we have to write it. So under square root of 4 h by kd, because here 1d remains. Okay, so 4h divided by kd under square root. So now substitute the value of 4 into 20, 380, that is thermal conductivity of that copper, and 0.005. So this becomes 6.29 watts. Further, so we have to calculate what is the heat transfer. It is given in watts. Watts is nothing but joules per second. Correct? So we have to calculate in terms of joules per hour. That is 6.29 into 3600 means 2644 kilojoules per hour. This is the heat transfer value. So this is how the answer we can calculate. Further, efficiency of the fin. Efficiency of the fin, that is second question. If fin which is insulated at the tip, given by tan hyperbolic ml divided by ml. Tan of hyperbolic 6.49, 6 divided by 6.49 into 0.6, that is 0.2566, or we can say 20.566%. This is the fin efficiency. So I hope you have understand, have followed this solution. Thank you.